Welcome to another video lecture on digital principles and computer organization. In this video, we are going to discuss about interface. So, generally, you can ask why we are going for interface circuits. So, this interface circuit will act as a interface between the input and output device to a processor. So, if you see here, one side of the processor, one side of the interface circuit, I have on connecting a input and output devices. So, which is called as port. Okay, it may be either a serial port or parallel port. So, what is the function of this interface unit is, so it will convert serial to parallel, or it will convert from parallel to serial. So, the other end of the interface circuit is connected to a processor. So, and it consists of a bus line called address, data, and control. So, what a serial port means? A serial port will send and receive a data one bit at a time, whereas a parallel port will transfer multiple bit of data simultaneously to and from the devices. Generally, the communication will take place, as I told you previously, we can communicate with the parser in a serial format or through a parallel format. So, let us discuss about what is the function of this input-output interface. This will provide a register for a temporary storage of data. So, if we want to store some data, which is from the input side or to the output side, we require some register, right? That is, it is also a temporary one. Okay. Then it contains a address decoder circuit in order to determine when it is being addressed by the processor. Next, it will generate a required timing signal. So here the why it require a timing signal is because each and every input and devices will operate at a different time. So it has to generate a required timing. Then it includes status register. Here example is KBD status, which contain the status information that which can be accessed by the processor. Next one, it includes the control registers, which will hold the information governing the behavior of the interface. So last one is if you perform any formal conversion in order to transfer the data between the processor and the input out pins. So now let us come to a parallel interface. So here I am going to connect a 32-bit processor to a interface, and it can be communicated with the help of asynchronous bus protocol. So whenever the master is sending a signal like master steady, so the interface will send the proper data. So after that, it will send the slave ready. So it is like a pagination signal. Next, this can be connected using a memory map IO technique. So next, in the left hand side, in the right hand side of the interface circuit, you have a input output devices. So if I want to connect input interface, so let me take one as a keyboard. Okay. So here I'm not going to use any control lasers since the interrupts are not used here. Okay. So here the input interface, I'm going to take it as keep KBD data. This is for data register. So whatever the data coming from the keyboard, it will be stored in the KBD data. Next, KBD status. So status is just once the data get received, the status pin, that is keying pin, goes to 1. Okay. So since the keyboard is a mechanical switches, so whenever the any key is pressed, it will generate a electrical signal, right? So this electrical signal has to be converted into a ASIC one. So this can be done with the help of the encoder circuit. So in between the interface and the uh, input interface circuit and the keyboard, you have to connect an encoder. So this mechanical switches will suffer from the bounces. So what is bounces means? So whenever you press a key, uh, it will produces some electrical signal, like so. So when it is pressed, the resulting in electrical connection being made, then broke several times before the switch settles in the post pressure. But it is lasts for 1 or 2 milliseconds, which will causes some enormous interrupt as a key is being pressed and released for several times instead of single person. So if I press only one time, so since due to the problem of bouncing, it will consider as a multiple times the key get pressed. So it can be eliminated by using a debouncing circuit. So the debouncing circuit is employed inside a encoder or inside a keyboard. Okay. So it can also be controlled with the help of the software. So whenever the software detects status spin, that is keying status equal to 1. So it is thinking that the keyboard value is already pressed. Okay. So with the help of some softwares like VHL and Verilog, we can control this one. Next, so the output of the encoder is nothing but a 1 byte of data, which represents the encoder character, and the valid signal goes to 1. So which represent the key is being pressed. Then this data is stored in the KBD data, and the KBD status is equal to 1. Okay. So now the character get occupied and the KBD status also get updated. So now we can see the input interface is like this. So the input is from the keyboard data. The output is KBD data. It is stored in the KBD data. Whenever the valid signal goes to 1. Okay. So now if the processor is requesting for the read operation, so the master ready should be 1 and the read and write signal must be equal to 1. Then it has to send some address, right? So the address decoder, it is from A3 to A31. So why it is not from A0 to A31 means A0 and A1 pin are not used here, and A2 pin is whenever it is 1, the KBD data will get stored. Whenever the A2 pin is 0, the status flag. So whenever the A2 pin is 0, the KBD data will be sent to the processor. Whenever the A2 pin is equal to 1, we can know the status of the input-output interface. Input interface. Okay. So in order to perform the read operation, it will send a address. The address so the address is being sent right to the address decoder. Okay. So if and I'm going to make A2 is equal to 0. So you can see the KBD data is going to the 2:1 mux. Then it will reaches the tri-state buffer. So here you can see since the master ready and the read write signal is equal to 1 and address also is generated. So from the address, the data from the KBD data is read by the processor. Okay. And you can see the slave ready pin is equal to 1. Also it is said. So here if I want to so you can see the status flag. So this is a circuit for a status flag. So here I have used two NOR gate, which is nothing but R and S. So in order to make in order to read the data, in order to write the data, so here the data pin is 1 and the master ready pin is 0. So you can get the output as 1. So the set pin is 1 and the read pin initially is 0. So set pin is 1 and R is 0. So you will get K in is equal to 1. So which means the KBD data get updated. Whatever the key get pressed, that will be stored in the KBD data. Next, I'm going to read the data. Therefore, I'm going to make master ready and read data equal to 1. So obviously my set pin goes to 0 and reset pin goes to 1. So the K in value is equal to 0. So once the processor read the data, the K in value goes to 0. So that is what it is mentioned in this diagram. Next, let us discuss about the keyboard to the processor connection. So on the left right hand side we already discussed. So between the processor and the input interface, you have a data, address bus, read write pin, and master ready and slave ready. Okay. So next let us discuss about the output interface. In the output interface, I'm going to make it as display data, display status. Then in the display, I'm going to connect data ready and the new data. So initially, whenever the display pin sends ready equal to 1, ready equal to 1. So the display status register goes to what? And the D out pin, this is a status flag, which is also goes to 1. Okay. So the processor will send the data and it gets stored in the display data. And it will make my D out into 0, then the new data equal to 1. Okay, so that the display pin will send the it will make the ready equal to 0 and it will accept the new data and it will display it. Okay, so and the cycle will get repeated. So here I can see the A2 is equal to 0 means it will perform the write operation. Okay, so here the A2 pin goes to 0. So the display, it will display the data. That is, the processor will write the data into the display data. So whenever A2 is equal to 1, it will perform the read operation, right? That is display status. So the state of the status flag is determined by the handshake conversion.